Hi guys, for this tutorial, or rather developer stream, I'd like to achieve some sort of RTS control using finite state machine based AI and potentially have some sort of FSM control that will be that we can easily add to an entity to be able to control it as long as there is a finite amount of states an entity can be in. And I've chosen an sort of real-time strategy sample because in RTS games you usually have some type of worker entity that gathers resources and builds structures. So today I'll try to implement a basic version of that worker type. It's going to be he can walk, he can wait, and he can gather resources. So if I can achieve that, then that should be enough, and that will form a basis for a finite state machine control for FXGL. Right, so this is what we have at the moment, which is nothing really. And I think we'll start with naming types. RTS sample type. So this enum is going to contain all entity types within our sample. So we'll have a worker. We'll have, I'm thinking Warcraft 3 kind of style. You have a town hall, which allows you to spawn workers, and you have a gold mine. And workers can go to the gold mine and gather gold resource. Let's have an interface for our resource. We want to know when the resource has been started, the gathering has been started. So on start gathering, and perhaps on end gathering as well. Let's have a concrete class for that, gold mine. Let's say there is a maximum amount of people that can gather gold. So something like max gatherers. Let's set it to 2. On start gathering, we're going to increase that by 1. On end gathering, we're going to decrease it by 1. But we should also be able to know if gold mine is full, so that there are no more people that can gather resource from that gold mine. It is full, return gatherers is max. That looks about right. We might as well have the amount of gold in there, but that's for some other use case. For now, just want to get the basic functionality there and then go from there on. So I've got these things. Right, I'm going to use gdxAI state machine, and I'm going to define work state for actually worker state. So these are going to be states that a worker can be in. So implement state. let's say game entity. I'll start with idle. I think idle is going to be for most states because it's very useful to have an initial state of idle so that the entity doesn't move and doesn't do anything. Let's have a state for walk. We'll need to override that to make the entity walk. Gather gold. And also another one to deposit gold back. So this will be this will make a nice symmetric API. We gather gold. This is where we get the gold from the gold mine. Then deposit gold is where we drop it off at the town hall. So walking is, yeah, so when a worker walks from the town hall to the gold mine, essentially is the same action as walking from the gold mine to the town hall. So I'm going to define it as a single walk state. The only thing that is going to be different is a particular variable, which is probably the target. Let's just use some easy way to get around this set property. So I'm going to set target as a property, and perhaps at some point we'll replace that as a target component or something. Then we're going to make the entity move, entity translate, target get position, subtract our position. This gives us the vector from the target to the entity. We're going to normalize that. And then multiply by the speed. Let's use 100 pixels and the typical time per frame. That should ideally be read from actual time per frame. We'll fix that some other time. So that will make the entity move toward the target at this speed. Gather gold. So we need to have some concept of a backpack or something. Let's create a backpack data structure, which is literally going to contain just one thing, which is the amount of gold. So get gold, add gold, that should be enough. Yeah. Let's have a backpack component. This is our way of adding something to the entity. Object component, backpack. Don't need constructor. We'll just create new backpack every time we create new component. That should do it. So what else we got? There we are, right. Gather gold, we can now override this thing. Have a backpack. Entity get component unsafe. We should ideally be checking for if such component is present. Since it's a sample, I'm not going to check for that. Get value. Backpack add gold 1. So this is going to run 60 frames per second. So that's 60 gold value per second, which is fine, I suppose. We could change it to a double and then have it so that one is added every second or something, but for now that's right. Deposit gold is going to be adding to some sort of world state. Right. Let's first create a world class variable in game vars. Going to put gold. So this is the gold in the town hall. I'm going to make it global because that should be alright for now. And that will allow me to do something like update FXGL get app get game state, and we can increment gold by the amount of gold available. So I'm going to copy this. And we also need to somehow reset the amount in here, which I'm just going to add the same. Backpack add gold minus backpack get gold. So that should technically set it to 0. We're not really interested in these ones. Yeah, that should be enough for now. Let's create some entities and have them in our game. Entities builder. Actually, I will need to create a factory just to make things cleaner. Let's have RTS sample factory. I'm going to set it so it does this thing automatically. Public entity new town hall. Gold take spawn data. So this is the typical method signature for spawning things. And this spawns a town hall. Oh, I call it RST. That should be RTS. DS sample time. Let's make it a circle, and let's set the color to red. Something big, and color red. With collidable components, because we want it to be able to collide with the worker at some point when he's depositing the gold. We need one of those for each type. So this is going to be worker and one more for the gold mine. our worker is going to be a rectangle, actually square, 40 by 40, and we'll set new color. And we'll use a random color. So every time a worker is spawned, he's going to have a different color. As for a gold mine, let's make it that and color gold appropriately. In which case we can just say get game world spawn town hall at 500 100. So that's top right, kind of. Let's spawn a few gold mines. Let's make 2 gold mine 100. That's top left. One more somewhere closer to the center, 400, 200. Actually, closer to the bottom right. Let's make it 400 and something like 500. So we'll have 2 gold mines, and workers will be able to spawn workers by clicking on the screen. For that, we'll need input. Get game world spawn worker, and we're going to spawn them at mouse cursor. Get position world. Right, our worker needs to have a backpack component before I forget. So let's add that. What else? Let's see this running. We should have a town hall and 2 gold mines. This is our town hall. These are 2 gold mines. And I can spawn a worker on click. Right, now we need to add, well, we actually need to create some sort of control that will be the bridge between gdxAI state machine and our FXGL entity control. And this will make part of the FXGL control API at some point. But this is all experimental at this stage. FSM, Finite State Machine Control, Abstract Control. So we already have our states in here. And what we want to be able to do is to pass this as a class. So it takes, so that it's type safe. Right, well, first we need to have the machine itself. It's called default machine or something. Yes, default state machine, and it takes E is the entity and S is the state. We need to type the extend entity because we want to be able to pass an entity and a game entity irrespective of the type. In which case this becomes T, and this is state of T. and this is the machine. Where's the factory? So I want to be able to do something like new FSM control, then pass worker state as the type, and then the initial state, which is idle. Something like that. So it should take the class and then the element of that type. It's going to be class of T. Right, we'll have to have the type, so the type extends the state of T, in which case this becomes class S. So this is state type, and then S is the actual state object, initial state. Well, we don't have the owner yet, because controls are created without entities attached to them, which means we'll have to attach owner at some later stage, and the initial state is that. So when the control is added to the entity, this is where we can set the owner. Alright, so we have to cast it back to T, because that could be anything. Update, we simply update state machine. And that should make our bridge, hopefully. Alright, so that works too. Alright, I'm not quite sure where it's going to change states though. So currently it's idle, and it'll stay idle unless I tell it to switch to something else. Which means we need to have some sort of conditions. And condition is that we have a gold mine to which to go to, right? So we need to write update here as well. And we need to be able to switch states. So let's add that first. Change states. Actually, we'll need the reference to the entity as well, because that's entity get control and save FSM control. So in the update, we need to search for gold mines and find the closest. Right. Get, what kind of query can we do? I think get cluster entity is probably the best thing we can do. Yep, get cluster entity to this, and the predicate is that the entity is of type entities. Get type of E is type gold mine, which is RTS sample type of mine. And also that it's free, so it's not full. It's not, it is a gold mine, and we now have to typecast it to the actual gold mine. Which means we need to have a component that allows us to move that to have access to gold mine. Object component where's the factory? Gold mine is here. So actually in the same way we could have added a town hall component or control to town hall, which then means we wouldn't need to keep that. And for now we're going to, because it's easier. So now we can actually obtain the component, and get component unsafe. So if it's a gold mine, then we definitely know it's going to have this component. Gold mine component. Get value is full, and we need not full, so we negate the statement. So filter, query the game world for the closest entity to our entity, which is the worker, such that the entity is of type gold mine and it is not full. I think that makes sense. Which optional, isn't it? Yeah. Which means we have to call if present, because it might be the case that both gold mines are full of workers. Gold mine. So if present, then use that gold mine as the target so that we can walk to it and change the state to walk. Yes, right, entity, set property, target. So that will make the worker walk towards the mine. And when we collide with the mine, we start gathering gold. That's the condition for gathering. If entity is colliding with the target, so this will then start colliding. It'll start collecting gold. We'll wait until there's 150 gold. The value of gold is 150, in which case we then switch to walking back, which is that again. But in this case, the gold mine, it's not the gold mine, it's the town hall that we're looking for. So FXGL, get game world. Get entities by type. We know there is a town hall in there, so that will return at least one element. In fact, it will return the only element. Get 0. So that will return town hall. We change the state to walk, so this will start firing. We're technically still colliding with the mine, which means we have to also check that our backpack isn't full. Something like that. Actually, here we have to also check that the target is actually gold mine. Is type could move that into a different statement, because we need to check if we're colliding and only then check who we're colliding with, because it could be the town hall, in which case we deposit gold as opposed to just gathering it. So if that, then we change state to gather gold. If target is type town hall, then there are no extra conditions. We simply deposit gold. Once we've deposited the gold back, which is here, we then change state to idle, which will then trigger that. So we have a cycle, which is good, because that should work then. Right, there we go. I think that should be it. Hopefully. Let's go and check. Cool. Seems to be working. And she should now be just walking between these two, because that's the closest one. Although I haven't really said anything about set the thing where we actually check the amount of people working in the gold mine. So on start gathering, on end gathering. This is something we should be setting at some point here. Because once it's started gathering gold, that is the thing that we do, which means at this point the target is still the gold mine. So we should be able to just do that. As soon as we start gathering gold, we can only get into this state if we are colliding and the target is of type gold mine. So we just do this. Target get component unsafe gold mine component get value on start gathering, and once we've gathered enough gold we are leaving the gold mine, so we should stop gathering on end gathering. Technically that should make that should only allow 2 workers to the same gold mine. Right, there's some check that isn't being fired. Well, it is fired, but we're checking it in a different place. Because when we're idle, this is still true, so we do walk towards it, which means we have to check just before the gathering. So this is where we start gathering gold, because it is fine to walk towards the gold mine, even if it's full, because eventually it will be empty. And just before we start gathering gold, that is here, we should check if it's full. If mine is full, actually if mine is not full, then do this. Oh, it's only the update, right? We need to override the enter state, because this is where we enter the state. This is the first thing to be called when we just have collided with it. If mine is full, then we'll have to change state back to idle, because there's nothing else we can do at this point. And this is the actual update, which means this cannot be true. Else we start gathering. So we don't actually need this, right? Because that is called when we exit the mine, exit the state, which is equal to exiting the mine. But at that stage, we've already changed the target. I suppose we could call it here, because technically that should only be fired once. Because we change it to change the state in here. So on stop, on end gathering. Let's print something here, just saying mine is full. Yep, so this guy couldn't collect it, and these guys also couldn't collect it. They're pretty efficient, actually. Let's add more of them. So there should be more messages saying mine is full. Right. I wonder if we can actually visually show that they're not, whether they're collecting or not, just to make sure. What if we change colors? So factory, start with color blue, which means not collecting. In which case we can collect actually we could just make them invisible while they're collecting. So that should stay there. State on start gathering. This is where they should disappear. Entity get view set visible false. And once they've stopped gathering, we should make them visible. So that should stay visible for a while, yes. So he couldn't collect, couldn't gather gold from the gold mine. So he had to stay there, and he actually went to a different gold mine. And that happens because we've changed the state to idle here. So it actually went to here and rechecked the gold mines that are available, which is pretty cool. It'd be quite interesting to also have a behavior tree implementation of that, and maybe even goal-oriented action planning. So there are several AI techniques to make them do what they're currently doing. I'm just looking for the easiest option. The state machine is sufficient enough for cases where we don't have many states. And I think this is pretty good because if we somehow make some of that code boilerplate, in which case we can just define workers saying lumber worker state. So that would be workers that go out to gather wood or something like that. Right, that seems to be working. I'm quite happy with that. And I think we've achieved the goal of this demo. And I'll see you next time. Thanks for watching.